We are going to start up on 10.3, which is talking about combinations. And our main essential question today is to be able to solve problems involving combinations and distinguish between a permutation and a combination problem. Okay? So the question is, what is a combination? Well, you've been throwing out this idea of a combination your whole life. You ask maybe somebody, hey, what's the combination for your locker? Well, you actually should be saying, what's the permutation for your locker? Because the combination in our definition right here, a combination is a grouping of objects where order doesn't matter. Does order matter when you give the combination to your locker? If you say it's 7, 4, 5, could they put in 5, 4, 7? No, it won't get them in. You got to give them the right order for that. So that's just an idea of it. And then another idea is choosing a team for kickball. Does the order that you choose your team matter? No, you can choose it in any order as long as you get the same guys you want. I guess maybe order does matter. You want to choose the best people first. But if you could choose whoever you wanted to, order wouldn't matter in how you chose them. Okay? So let's answer this first problem right down here, is how can I solve a combination problem? Well, Mr. Benson is at it again. He's going to Papa John's because he's hungry, and they have a special. You can buy one large 3-topping pizza for $9.99. If Papa John's has 15 different toppings, how many different combinations of pizza could Mr. Benson make? Well, I'm going to go back to my buckets. Okay? So these buckets are going to represent how many different toppings I can put on there. So I need, since I got 3 toppings I can put on there, I'm going to have 3 buckets right here. 1, 2, 3. Okay, remember, we multiply our buckets. And how many different options do I have for my first one? Well, I have 15 different options for my first one. Now, I don't like to double up on things. I know I could probably put pepperoni, pepperoni, and pepperoni again. But let's say I can't. And then how many different options do I have for my second? Well, I have 14. And for my third, I have 13. Now, the issue we have here is there are different arrangements of this, and we got to get rid of any duplicates. There's duplicates is what I'm trying to say here. We need to get rid of them, right? I could get a pepperoni and then sausage and then cheese, but that's the same thing in our scenario as cheese and then sausage and then pepperoni, okay? And so I got to get rid of all that duplicate. So what I'm going to do is I got to divide by how many different ways I can arrange those toppings. So I'm going to put 3 more buckets on the bottom. And how many ways can I arrange those 3 toppings? Well, I have 3 options for the first one, 2 options for the second one, and 1 option for the third one. And this will actually tell me how many different combinations of toppings I can choose for my large pizza. So let's just put this in our graphing calculator, our calculator right here. So I have 15 times 14 times 13. I'll push enter to get that top number, and we're going to divide that by 3 times 2 times 1. And that tells me that there are 455 different combinations of toppings that I can put on my pizza. Now, there's a formula for this. If you don't want to use my bucket method, and that's okay, you don't have to. They give you a formula. It's called NCR right here. So the N represents how many toppings there are. The R represents how many toppings you're going to put on your pizza, or how many you can put on your pizza. And here's the formula for this scenario. So let's just apply it right here. We have 15 toppings. C, we can put 3 on our pizza, and that's equal to 15 factorial all over, I don't know why I put an I there, 15 factorial all over 3 factorial times 15 minus 3 factorial. So let's just put that in our graph or our calculator and see what that comes out to be. So we have 15 math prob factorial divided by, and I'm going to put this all in parentheses, 3 factorial times 15 minus 3, and then we're going to make that factorial. Close it off, and let's see what we get. Got it again. 455 different combinations of ways to make my pizza with 15 toppings and 3 toppings on the pizza.